Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Best practices for long-term model maintenance. Model maintenance and updates are critical components of the GenAI lifecycle. The longevity and efficacy of a model are significantly influenced by the practices employed in its maintenance. Best practices for long-term model maintenance ensure not only the continued relevance of the model, but also its ability to adapt to new data and changing environments. This lesson delves into these best practices, highlighting their importance and providing actionable strategies backed by empirical evidence and expert insights. A foundational aspect of long-term model maintenance is the establishment of continuous monitoring systems. Continuous monitoring enables the timely detection of performance degradation, which can occur due to various factors such as data drift or changes in underlying data distributions. Data drift refers to the change in model input data that can lead to a decline in model performance over time. Implementing robust monitoring frameworks allows organizations to capture these shifts and make informed decisions about when to update or retrain their models. For instance, companies like Netflix utilize A/B testing and automated monitoring systems to ensure their recommendation engines remain effective as user preferences evolve. Moreover, the integration of feedback loops is a pivotal practice in maintaining models effectively. Feedback loops provide a mechanism for leveraging user interactions and outcomes to refine and improve model predictions. By systematically incorporating user feedback, models can adapt to new patterns and anomalies that were not present in the original training data. This iterative process of learning from real-world data is crucial for maintaining the accuracy and reliability of models over time. Google's search algorithm, for instance, continuously adjusts and improves based on user interactions, ensuring that the search engine remains relevant and effective. Another essential practice is the periodic retraining of models. Retraining involves updating the model with new data to prevent obsolescence and maintain performance. The frequency of retraining depends on the volatility of the data environment and the model's criticality to business operations. High-frequency trading algorithms, for example, require constant retraining due to the rapid changes in market conditions. Conversely, models in more stable environments may require less frequent updates. The key is to establish a retraining schedule that balances computational costs with the need for accuracy and relevance. Model versioning and documentation are also critical components of effective model maintenance. Versioning involves maintaining a comprehensive record of all model iterations, including changes in architecture, hyperparameters, and training data. This practice facilitates the rollback to previous model versions if a new update leads to unexpected performance issues. Proper documentation ensures that all stakeholders, including data scientists, engineers, and business leaders, have a clear understanding of the model's evolution. This transparency is vital for troubleshooting and enhances collaboration across teams. Git, a version control system, is widely used in the industry to manage code and model versions, allowing for seamless tracking and collaboration. Furthermore, the adoption of explainable AI methodologies is becoming increasingly important in model maintenance. Explainable AI provides insights into the decision-making processes of models, making it easier to identify and address biases or errors. By understanding the internal workings of models, practitioners can implement targeted improvements and ensure compliance with ethical and regulatory standards. The European Union's General Data Protection Regulation, for example, emphasizes the need for transparency and accountability in automated decision-making systems. Implementing XAI not only aids in model maintenance, but also builds trust with users and regulators. Cross-functional collaboration plays a crucial role in the successful maintenance of models. Model maintenance is not solely the responsibility of data scientists, but requires input and cooperation from various departments, including IT, business, and legal teams. This collaborative approach ensures that models align with organizational goals, comply with regulatory requirements, and are technically sound. Companies like Spotify have adopted cross-functional teams to manage their recommendation systems, ensuring that diverse perspectives contribute to model development and maintenance. Data quality management is another cornerstone of effective model maintenance. The accuracy and reliability of models are heavily dependent on the quality of the input data. Implementing rigorous data validation and cleansing processes helps prevent the introduction of errors and biases into the model. Regular audits of data sources and pipelines are necessary to maintain data integrity and ensure that models are trained on relevant and accurate datasets. Poor data quality can lead to erroneous predictions, ultimately affecting business decisions and outcomes. Therefore, organizations must prioritize data governance and quality assurance as part of their model maintenance strategy. Lastly, the scalability and flexibility of the model infrastructure are essential considerations for long-term maintenance. As models evolve and new technologies emerge, it is crucial to have an infrastructure that can accommodate these changes. Cloud-based platforms, such as AWS and Google Cloud, offer scalable solutions that enable organizations to efficiently manage computational resources and deploy updates. These platforms also provide tools for monitoring, versioning, and collaboration, streamlining the maintenance process. Embracing flexible and scalable infrastructure ensures that models can adapt to changing demands and technological advancements. In conclusion, best practices for long-term model maintenance are multifaceted and require a comprehensive approach that encompasses continuous monitoring, feedback loops, retraining, versioning, cross-functional collaboration, data quality management, and scalable infrastructure. By implementing these strategies, organizations can ensure the sustained accuracy, relevance, and reliability of their models, ultimately driving better decision-making and business outcomes. The integration of explainable AI and adherence to ethical and regulatory standards further enhance the trust and accountability of models, fostering a more transparent and responsible AI ecosystem. As the field of artificial intelligence continues to evolve, these best practices will remain indispensable for organizations seeking to leverage the full potential of their AI models. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.